Hi guys, welcome back to this solution. And I'm super excited to have you back with me here. Today we'll be solving another question on the topic measurement of heat energy. And the question goes thus: what is the total amount of heat energy required to convert 0.5 kilogram of ice at minus 15 degrees Celsius to into steam at 100 degrees Celsius? And we are given the specific heat capacity of ice from 2100 joules per kilogram per Kelvin. Are given the specific heat capacity of water to be 4200 joules per kilogram per Kelvin. We are given the specific latent heat of ice and also the specific latent heat of steam. Now, the first thing we'll be doing to solve this question is to bring out our parameters. So, first of all, we know that we have to find the total amount of heat required. We are finding the total amount of heat required. Also, the mass of ice given is 0.5 kilogram, and the temperature of the ice is minus 15 degrees Celsius. But to convert this mass of ice at minus 15 degrees Celsius to into steam at 100 degrees Celsius, so theta 2 is equals to our steam at 100 degrees Celsius. Now we have all our constants given in the question. Now this question is a very simple one, honestly. Let me draw a simple line for us to demonstrate this. Now let's take this as our temperature scale. Sorry that it's not that straight. My hand is not unable at this. So now we have been told that the mass of ice, the 0.5 kilogram of ice, is presently at minus 15 degrees Celsius. So our ice is here. Let's say we have minus 15 degrees Celsius. This ice, we know it is water, right? So let's say we have our 0 degrees Celsius here. Then we have 100 degrees Celsius here. Now, our ice is presently at this point here. It's presently at this point here of minus 15 degrees Celsius. But to take it from this point here up till this point where it will boil at 100 degrees Celsius and evaporate and turn to steam at 100. We are not just taking to 100. Please note that we're taking to 100 and we will also boil it at 100 such that we convert it to steam at 100. Note that we have to convert it into steam at 100. We're not just taking to 100. You boil it at 100 and what? Vaporize it at 100 into steam. So now, to make this question easy for us to solve, let's look at what we are solving for. The first thing we are solving for, because we can't just calculate the heat energy required to convert it from minus 15 straight to steam at 100. We can't do that. We have to break our solution bit by bit. And how are we breaking it bit by bit? We will have to first of all calculate the heat energy required to take it from minus 15 up till 0 degrees Celsius. So we have to take it from where? From minus 15 to 0, that's our heat energy 1. After that, calculate the heat energy required to melt the ice at 0 degrees Celsius. So we have our heat energy 2. That will melt it as well at 0 degrees Celsius. Thirdly, we'll take it from 0 again up till 100. From 0 to 100. That's our heat energy 3. Then lastly, we will now vaporize the water at 100 now into steam at 100 here. So we have our what? Energy 4. Now, to take the ice from -15 to 0, we'll be utilizing mc theta to what? Convert to to raise the temperature of the ice from -15 to 0 degrees Celsius. To melt the ice at 0 degrees Celsius, so you can convert it to liquid, to what? To liquid, to its liquid state, we'll be using ml. To change the temperature of the water now from 0 to 100, we'll be using mc theta. And finally, to melt the what the to vaporize, to boil the water at 100 now, to change its state from liquid to gaseous state, which is the steam, we're using ml again. You should realize that during the change of state, the formula we're using is always ml, ml, ml. But when it is between the states, like from -15 to 0 and from 0 to 100, we're using mc theta. This should ring a bell that when it involves a change of state, we use ml. But if it is just changing the temperature of the substance within a state, we use mc theta. Now let's solve. Let's start with our H1. Our H1 is equal to mc theta. Our mass is 0.5 multiplied by, now we are still in the solid state here, right? It's moved from -15 to 0. It is still ice. So the C we are giving, the C that we use here will be the C of ice. This stands for specific heat capacity. C stands for what? Specific heat capacity. So the C of ice we are to use is 2100. 2100 multiplied by, change the theta. So it's moving from -15 to 0. So 0 is more than 15. Right? 0 is bigger, is 0 is more than -15. So we put 0 first. 0 minus -15. So we're having 0.5 multiplied by 2100 multiplied by 15. So 0.5 multiplied by 2100 multiplied by 15 because that's 15,750. So our H1 equals to 15,750 joules. This was our heat energy required to take the ice from -15 degrees Celsius to 0 degrees Celsius. Now let's get our H2 now. Our H2 equals to ml, which is the mass of the ice, is same thing as 0.5 multiplied by this L now will be the specific latent heat of ice. That is the heat required to change the temperature, to change the state of ice from its solid state to its liquid state without a change in temperature. So the value for that is, we are given the question also, 336,000. So 0.5 multiplied by 336 equals 168,000. So we have our H2 to be equals to 168,000 joules. Now our H3 now, the heat required to raise the temperature of the water now. No, it was ice at -15. It was ice here. It was ice at this point here. Then we took it from here to 0 now, to 0. Then we now melt it at 0 now. When it got to 0 here, from -15 to 0 here, it was still ice at 0. Please note that it was still ice at 0. when we got this value here only from -15 to 0, but it was still ice there. We now use this one here to melt the ice now at 0. You get that? We use this value here to what? To melt the ice at 0. So we now convert it from ice to liquid at 0. Now the next step now is to what? Now to take it now from liquid at 0 to liquid at 100. So now our H3 equals to mc theta. Our mass is 0.5 multiplied by, now since we're talking about liquid now. It is now liquid at 0. So it is now water at 0. Let me put it that way. It is now water at 0. So we'll be using the specific capacity of water now, no, and not longer of ice. So our C for water is 4200 multiplied by infinity theta. So it's moving from 0 to 100. So 100 is bigger. So 100 minus 0. So 0.5 multiplied by 4200 multiplied by 100 equal to 210,000. So we have 210,000 joules for our H2. Now, we have taken it to this point here now. It has moved from liquid at 0 to water at what? At 0. The next thing is now that you want to now convert it to steam. You want to change the state from liquid to vapor. So you want to change the state of water now because it is still liquid, but we are being asked to convert it from ice into steam. So we want to change the state now into steam now at 0. So we have to use H4. H4 equals to ml. Our mass is still 0.5 multiplied by, now the latent heat required to change the state of a substance from its liquid state to its gaseous state without a change in temperature is called the specific latent heat of vaporization. So we are given in the question specific latent heat of steam is equals to 2.26 multiplied by 10 to the power of 6. 2.26 multiplied by 10 to the power of 6. That gives us a value of, so our H4 equals to 1.13 multiplied by 10 to the power of 6 joules. Now we've gotten all our values now. With all this heat now after we've converted we've used this value here, we've used this formula here to convert our liquid to we've used this value here to boil our liquid away into steam. So we've now arrived at what? At steam at 100 now. That is where we asked to stop. So now the heat required now to take it from -15 to steam at 100 will be the addition of all these heat, all these values of energy you are saying. Because these are the energies required to take it from -15 to 0 at 0 again, and from 0 to 100, then you boil again at 100. So the total heat required now, the total amount of heat required to convert 0.5 kilogram of ice at -15 degrees Celsius into steam at 100 will be the addition of all these heat we've gotten. Now let's do that now. So the heat required H is equals to H1 plus H2 plus H3 plus H4. Okay, I won't now our capital H will be equals to H1 is 15,700, 750, sorry, 750 plus our H2 is 168,000. Our H3 210,000 plus then our H4 1.13 times 10 to the power of 6. So the total energy required now, the total amount of energy required to change the state to convert 0.5 kilogram into steam at 100 degrees Celsius will equals to 1.52 times 10 to the power of 6 joules. So this is this is our final answer. So I believe this is very clear, right? I believe it's very clear. So that this will be all for this question. Endeavor to like the video if you have learned one or two things, and also if you haven't subscribed to my channel, kindly do so and click the bell icon beside it so that you can be notified anytime I drop a new educational content like this. And if you have any confusion, kindly drop it in the comment section for me. I will gladly answer all questions and any confusion you are having. See you again.